Uh, in today's video, we will start talking about object-oriented programming. So, the object-oriented programming is basically a different way of thinking about things. It's all the concepts that we have studied in the programming fundamentals with Java are going to be applied here. If you want to learn those, I recommend you should go through all of those before coming to this playlist or this series. The link will be in the description. But in this series, we will cover all the core concepts of object-oriented programming with examples. Uh, and we will build a foundation of how we can think in a at a large scale. So every large scale software is going to have object oriented programming. Like you can't make anything big or anything gigantic without the concept of object oriented programming. So we will get to that what this is. So in Java, if you are familiar with Java, you know that in Java everything is done in classes. So everything that we do involves classes. It doesn't happen in other languages, but Java is purely an object-oriented programming language. Let me show you what I'm talking about. So here is a simple program that prints hello world, right? So this is my program that prints hello world. But notice it has a main method, right? So as expected, every class has a main method, and therefore we know that each class must have a main method, right? So main method is where our code starts executing. So now, as you can see, this is a simple program, but it still has a class. So as you can see, let's get rid of this for now, and let's remove this as well. And here is a very simple program, the probably the most simplest program, and it still has a class. So everything in Java is done in classes. Here we can have a multiple method, like suppose that there is method 1 and there is method 2. So we have multiple methods defined here, but everything has been done in a class. So this is how we think about classes. So let's look at a bit more about this. So what is a class basically? So class is basically a blueprint which might hold properties of a certain thing, right? So it might hold properties about anything at all. For example, suppose car is a class, right? So car is a class since each car has identical properties. Each car will have a speed, each car will have a license number, each car will have an engine, each car will have a top speed, braking, everything. So these are common functionalities. So when we want to create multiple instances of something, we enclose it into a class. So that helps us in reusability and for better managing our code. So this is basically what a class is. So class is basically a blueprint which holds relevant type of data. Let me give you another example. Um, suppose you want to store the record of a student. Now student is can be a class because we know every student is going to have a GPA, every student will have a name, every student will have a registration number, every student will have multiple methods, like he can register courses or he can withdraw courses, or similarly he can pay his fee. So now instead of creating variables or arrays, we will have to create them separately for each student, right? And this will become tedious and inefficient. So instead of doing that, we enclose it in a class, since we know that there are going to be multiple students. So instead of creating every student separately, just create a general student class, and then let's create a specific person of that class. It is just like the and all thing. What I mean by that is that a class is a general concept. It's just a blueprint. It's not real. It's what we imagine. It's how we design. For example, when a car is getting made, first it is designed, right? So you can think of it as a design. So this is what a class is. And when we create a physical aspect of that class, then that is called an object. For example, a student. student can be anyone. So that's why we have a student class. But if we create a student, for example, if we create a student called Jake, now Jake is an object because it is an instance of that class. So this is how classes look like. We will see more about them in great detail. So uh, you already know how to use classes. So if you have watched the Java series, you know that we have used string and scanner class. Similarly, we have used file class, we have used exception class. So these are all classes, right? So let me give you an example. So suppose uh, let's use the scanner class for now. We have used it numerous times before. So I want to show you one thing. So now to create an we have imported scanner class in our program. So now we know that scanner is a class. It is already a part of the Java. It has been already made. So it will have uh, so our scanner class will have a lot of functions. It has a lot of functions. It has a lot of variables in it. So now we can create its subject, and we can use its functions and variables. So to create an object, you need to write the class name, then the keyword. I'm gonna call it input, and I'm gonna use this system.in constructor. So now we know scanner is a class since it has relevant properties. It is just a blueprint. But now I have created this object called input. So now I have access to all functions of scanner class because of this object. So object is basically a physical aspect of the class. It allows you to access the data members or the member functions of that class. So this is what I'm trying to show you. So that's how class works. And now we will learn to create our own classes. So now this is something new. So what is a class? So class, as I explained before, it is a blueprint, right? It is a blueprint. It is a general concept. It is like a design of something or some quantity or anything. And when we create a physical aspect of that class, that's what we call an object. So if you look at this example here, they have written that if A is a class and Bala is type of Bala is everything. So what is telling that suppose we have a class called A. So this is a class called A, right? So I'm gonna call it A. It has a lot of variables defined in it. It also has a ton of functions in it. So this is a complete class. So to use its functions or its variables or to access its variables, we need to create an instance of that class. So to create an instance, we create an object. So object is an instance of class. That is the physical appearance of the class. So this is what we will create. And let's look at a difference between primitive type values and class type values. So we know that. Let me show you. Let me illustrate that concept. So suppose you have created a primitive. You have created a variable of integer type, right? So suppose you have created int. Let me write it in our code. So suppose we have created a variable called int. I'm gonna call it data, and suppose it has a 12 for now. So now this data variable will only hold one value, right? It can't hold more than one value. It can only hold one value at a time. But in class, this thing changes. We aren't restricted to one variable. So for example, suppose we have a class called student, right? So this is a student class, and for now, it has three it has three function data members. So before you think about this, so a class has so here we have seen that a class can only contain functions, but that's not true. A class can hold data members as well. It can hold variables. For example, I can add data members like int data, or I can add int or I can add string name. So as you're seeing here, a class can have variables and functions as well. So suppose this is a class called student. So this is a student class, and it has all this defined into it. It has three variables, and it has three functions, right? You can have hundred of variables. So when we create an object of this class, suppose we create an object of the class called so suppose here we create an object of the class, and we are gonna call it s1. So s1 roughly means that student 1, and now an object is created in memory. So now what will happen? First of all, the value will be memory will be allocated for these three variables. So you can think that three little blocks are formed since there are three variables. So this is the first one, this is the second one, and this is the third one, right? And this block will store uh, this block will have a name. So in this block we have the name, and here we have the registration number, right? And in the last block we have the GPA. So now when we create an object of a class, all its variables are created. So now as soon as you create this object, that is this s1 object, all three variables will be created in memory. You can think of it like blocks. So suppose blocks are created, so now our memory has three blocks. So this is our object s1. It is pointing toward this object. So it is an object, and in memory three blocks are allocated for that object, right? Since our class has three of variables, right? And this is what's an advantage of objects. In traditional data, for example, if you have an integer, you can only hold one value, but an object can hold multiple values. For example, now it will hold registration number, name, and GPA, all these things at once. And when you make an object, you allocate memory for all its uh, data members, and an object points towards all these data members. So this is and let's see. So a class can have data items and methods, right? So a class can have data members as well as methods, and object will have access to all those, right? And these data members are called members, and data items are called fields or instance variables. So this is just the theory part. And how we create a class. So class is created like this. So you to declare a class, you use this uh, variable. First you write the class name like this, and then you write the class object name. So previously I created use student class, and I created as one object of it. And then to create a new to create a new object, here we just declared the object. But to create an actual object, in other words to initialize it, I have to use the new keyword, and then we have to use the class name, whatever it is. So and instead of doing this in two lines, you can do this in one line like we did before. Like we use the scanner class, then we gave the object name that is input, then we use the new keyword, and then the class name. So you are familiar with this terminology. And so instance variables are created like this. So this is how we create variables of a class. So first you have to write the keyword public, just like methods, and then you have to write the data type and then the variable. So just like the uh, um, like we saw earlier, and then you can access these variables by creating an object. And similarly, You can create methods. So methods can be created. You have to use the public keyword, and then you have to specify its return type, and then you have to write the method name. And one more thing, we don't have to use static anymore, since static is only used when you don't want to create an object. But now in object-oriented programming, we want to create objects. That's why we are not using static anymore. And here we see that to call any method, you simply have to use the object name, then dot operator, and then the method name. Uh, we have done this before as well. So that's it for today's video. In the next video, we will see the code section of it. Thank you for watching.